In class today we talked about categorical sentences, all P or Q, no P or Q, some P or Q, some P or not Q, and how to symbolize them. And we began talking about sentences that are like categoricals but have either complex subjects or complex predicates. What I want to do is I want to start by going over some examples that are either identical to, as we'll see, or related to the one that hung us up in class, and then go on to some other examples from the book so that we can get a grip on how to do this. So let's start with this. All lions are dangerous if they're awake. Thinking about how to symbolize this, first we ask ourselves, is it like one of our categorical forms? The answer is yes. It's like all P or Q, but it's a bit more complex. In particular, it's a statement about all lions, and it's saying that all lions fit a certain description. If we want to make a statement about all lions, the way that we do it is we say for all x bracket, if x is a lion, then. This is really important. To make a statement about all members of a certain class, it's universal, bracket, specify the class, give an arrow. That's what we do. Now for the next part. Okay, this is the form the sentence is going to have, but at this point, ignoring the quantifier kind of helps. We're being told something about all lions. So suppose that x is a lion. Ignore the quantifier for the moment. If x is a lion, what are we being told? We're being told that x is dangerous if awake. That's what we're saying about any particular lion, and since the sentence is universal, it holds for all lions. So we made it into a sentence about all lions by doing this. Then we thought, for any particular lion, what are we being told? This is what we're being told. That completes the symbolization. Now come to this case. Some lions are dangerous if they're awake. Well, this doesn't actually follow from the universal for reasons we discussed in class. A sentence like this could be true if there weren't any lions. In fact, it would be true if there weren't any lions. We won't rehash why we say that. Just keep it in mind. But nonetheless, we're going to see some parallels here. So this is a sentence about the class of lions, and it's saying that at least one member of that class has a certain property or fits a certain description. That's how we say such a thing. At least one x is such that it's a lion, and there is at least one lion such that. The and here is rather like saying such that. Such that what? Well, take a lion that fits this description. If a lion fits this description, what do we know about it? It's dangerous if awake. If it's awake, then it's dangerous. So, this is our symbolization. The universal doesn't imply the particular, but it's consistent with it in a certain sense. It allows for the particular. Likewise, the particular certainly doesn't imply the universal, but it's consistent with it. It doesn't rule it out. It's just the special case where there is a lion and it fits the description. So far so good. Figure out if it's universal or particular. If universal, get a form like this going. If particular, get a form like this going, and then ask yourself, in the universal case, take any old lion. What am I being told about it? In this case, take a lion that fits the case we're talking about, that fits the situation we're talking about. What am I being told about it? And you notice the similarity here. The predicate's the same in both cases. That seems like it should be true, and it is. Now, move to the negative cases. No lions are dangerous if they're asleep. This is like a universal negative, but because, more to the point, it's a universal categorical that is modeled on, it means that we're saying something about every lion. And so just as before, if we want to say something about every lion, we do it this way. Now, this is the point where ignoring the quantifier helps. So suppose we've got a particular lion X. If this generalization is true, what are we being told about this lion? Well, since no lions are dangerous if asleep, then the lion X is such that if it's asleep, then it's not dangerous. Okay? That's where we got hung up in class, but thinking about it even a little bit carefully, you can see that this is right. Okay? Pick any lion you like. What the sentence is saying is if it's asleep, it's not dangerous. So there we have it. Now, we come to the sum version, the similar version, but with sum. And this is where we need to be a bit careful, but the lesson that we learned about parallel constructions from here will serve us well here. Okay? So once again, we notice that since it's a statement about lions, but it says that there exists a lion of a certain sort, we start with an existential quantifier, a bracket, name our subject class, and put an and. And now we ask ourselves, okay, suppose we have a lion that fits this situation. It's one of these lions that fits this situation. What are we being told? We're being told this lion is such that if it's asleep, it's not dangerous. If this lion is asleep, then it's not dangerous. And once again, we see the similarity in the construction. The predicate stays the same. What we noticed is that we had to be careful here in thinking about the predicate. The way to get it right, as I said, is to say, what are we being told about any particular lion in this case? And what we're being told down here is that there's some particular lion that fits the predicate. So that gives us a bunch of cases where we have a complex predicate, and it's a complex predicate that's a little bit challenging, but if you can understand how this worked, you should be in good shape for some of the other examples. So let's carry on here. We're going to look at some more examples. Okay, some students were worried or upset. Some students were worried or upset. How do we do this? Well, first we notice that it's rather like a particular affirmative. It's a statement about students, but what it's saying is there exists at least one student who fits a particular description. That gets us started. Now what I want you to do is pause and go ahead and complete the symbolization, and then start the lecture again and see if you got the same answer I did. So pause, finish this one, and then come back. Okay, well, I got you started. If we want to make a claim about at least one student, here's how we do it. So suppose we've got at least one student fitting this description. What do we know about this student? We know that the student is worried or upset. So that's pretty straightforward. It's like some P or Q, but the predicate is more complex. Let's try a different example. All the commuters were tired and irritable. This time I'm going to let you do it entirely on your own. Use C and T and I. Pause the lecture, do a symbolization, and then come back and we'll see what we get. Well, it's a statement about every member of the class of commuters. So we know that it starts this way. And now, as before, we say, take a commuter. What's the sentence telling us about this commuter? It's telling us that this commuter X is tired and irritable. And the sentence overall says that this applies for any commuter. And so this is the end result. All the commuters were tired and irritable. there are administrators who are neither competent nor hardworking. This isn't in our standard all-sum language, but you should be able to see what kind of categorical it's like, and you should be able to take a pretty good stab at symbolizing it. So once again, pause the lecture, try to come up with a symbolization using A, C, and H, and then restart the lecture. It's a statement about administrators, and it says there exists at least one administrator, at least one administrator that fits a particular description. So we've gotten ourselves started. Now we've got to figure out what the description is. So let's take one of these administrators. X is an administrator, and the administrators we have in mind are the ones who fit the predicate here. So X is what? Neither competent nor hardworking. Well, we know there's more than one way to do a neither nor. Doesn't matter which one we pick. We'll do it this way just because we have to pick. X is an administrator, and X is neither competent nor hardworking. So there we have it. Compound predicate. Once you get started, you ask yourself, if we have an administrator who fits the predicate, what are we actually saying about that administrator? And we get our answer. All munchkins are either big and sloppy, pardon my misspelling, or tiny and neat. This one's a little more complex. Here are the sentence letters I want you to use. Pause the lecture. Come up with a symbolization. It's a statement about all munchkins. So it begins this way. That's how we start a statement about all members of a certain class. Now, once again, so if X is a munchkin, what are we being told about X? We're being told X is either big and sloppy or tiny and neat. Let's get more than one kind of bracket in here just to make it easy to read. Either X is big and sloppy, or X is tiny and neat. That's what the sentence says. Okay, so that one's not too bad. Complex predicates, a little more complex than some of the ones we've looked at, but if you think about it in the way I've been suggesting, you should come up with the answer pretty straightforwardly. This one's a little different from the ones that are in the book. The one that I just, the few that I just did here were in the book, and this one isn't, but let's see how you make out. No criminals are jailed if and only if they're convicted. Give it a stab. It's like a universal negative. So we get started this way. Now what are we being told? If X is a criminal, it says, well, no criminals are jailed if and only if they're convicted. So X is not jailed if and only if convicted. Now, actually, it turns out in this case there are two ways we can think about it. So it's not true that X is jailed if and only if I'm going to have to use, unfortunately, since I don't have this computer set up correctly for the if and only if, I'm going to use an equal sign here. But that's fine. We can do it this way. And we need to have a different predicate here, so we're going to use C sub 1. So C is criminals, C sub 1 is convicted. And that's what we get. If X is a criminal, then it's not true that X is jailed if and only if convicted. But if you came up with something like this, you were also right. because it turns out that this, whoops, we need a subscript here, and this are two different ways of saying the same thing. But it would be perfectly okay to go for this one. X is a criminal. What are we being told? It's not true that X is jailed if and only if convicted. Okay? Every student who cheats will fail. Now we're talking about a complex subject. So give that a try. Every student who cheats will fail. How do we do that? Well, it's like a universal affirmative, but we got to be a little bit more careful. It's about students who cheat. What's a student who cheat? It's something that's a student and cheats. So we had to specify the subject with a compound expression. It's a sentence about students who cheat. What are we being told about students who cheat? If X is a student who cheats, then the sentence is telling us X will fail. So as before, we started with a universal and we picked out our subject class and then put an arrow. We just had to be more careful about picking out our subject class, and that's what we got here. Once we picked out the subject class, this one was easy. No employee who works overtime if he or she is asked will be fired. Okay. Give that a try. Pause the lecture. See what you come up with. Well, it's like a universal negative, so we know it's going to start this way, but we've got to specify the subject carefully. The subject is employees who work overtime if asked. So to fit the subject class, X has to be an employee and X has to work overtime if asked. So we'll use W for works overtime. It doesn't really matter. You can pick your own, but you'll get the idea here. If asked, then X works overtime. There is the subject. Employees who, if asked, work overtime. The sentence is about those kinds of people, and what's it saying about them? It's saying none of them will be fired. Okay? So, universal sentence about all employees who, if asked, work overtime, and being told that for any X fitting that description, X won't be fired. All politicians who lie or commit fraud will be excoriated. And that's the end of our row. Just was checking here to see if I'm right about that. All politicians who lie or commit fraud will be excoriated. Pause the lecture. Give that a try. And see what you come up with. Well, it's a sentence about all members of a certain class. What class? Politicians who lie or commit fraud. What's the who doing here? It's working like an and. To be in the subject class, something has to be a politician and has to be something that lies or commits fraud. I'll use F. If you use C, that's fine. It doesn't matter. What matters is that we have clearly distinguished the bits that we need here. So there is our subject. To be the subject, X must be a P and an L or an F. And we're being told that anything in that class will be excoriated. Now some of these examples are a bit complicated. What I've done here is I've solved the problems in the text, but I'll be giving you some more to look at. What I hope is clear is for these cases with compound subjects and compound predicates, how you think about them, so that when you approach one of these, either just as an exercise or in class, you've got a reasonably systematic way of coming about it. But in the meantime, if you need to redo any of this or listen to it again, by all means do that.